Hey everyone, welcome back. In our last video, we learned how to manufacture this valve core removal tool seen here in setup 1. Well, today we're going to go ahead and do our second setup on the reverse side. So whenever you're ready, let's go ahead and get started. So the first thing you want to do now is come on up here and let's start a new design. And we're going to go ahead now and save it here and make sure it's the location here is where you want to save it. And we're going to call it valve core removal tool setup 2 and go ahead and save. Let me fix that real quick. Alright, once that's done, let's come on over here to our soft jaws and vise and right click insert into current design. And this location is good, so I'm going to go ahead and select OK. Okay, next thing you want to do now is come on over here to our valve core removal tool and right click insert into current design. And we're going to move it up and over, and so it's in close proximity here to our soft jaws. So I'm going to move it over just a little bit. And then I am going to rotate this guy 180 degrees like that. And it's very important to make sure that this little, I'm going to hit OK, and it's very important to make sure that this line right here is parallel to this line right here. Okay, so I'll say it once again. It's very important that this notch or little slot here, okay, or this line right here, make sure it's in the X direction, going left to right or parallel with this guy. Okay, once that's done, you're good. All right, finally, all right, so now we just need to assemble it. So we got to make sure that this face right here, okay, this face right here is resting on this face right here. Okay, so we can go ahead and assemble that now. So let's come on up to assemble joint. I'm going to click on this midpoint right there, and this midpoint corresponds to this midpoint right there. And I'm going to go ahead and select OK. So when you're done, you should have something just like this, with this line should be parallel with that line. Okay, that looks good. Okay, once that's done, let's come up and change our workspace from design to manufacture. I'm going to go ahead and close out my data panel. And usually the first thing you want to do when you start manufacturing something is to do a new setup. So let's come on over here, click on new setup. All right, so the first thing we're going to want to do now is set this to milling. Make sure this is set to milling. All right, and then we're going to come on over here to model. We're going to select that guy and we're going to click on that guy. Okay, and then for our origin here, we're going to select, let's do a selected point, and we're going to select this bore or hole diameter right there. And then for our orientation, we got to set up our X, Y, and Z axes correctly. So I'm going to come on down and I am going to select X and Y axes. Okay, and so if you look here, this blue button is asking us, where is there a line or feature that's in the X axis direction? Well, I notice this line right here is in our X direction. So I'm going to click on that line. Okay. And now it's asking us, well, hey, what about our y-axis? What about a line that's in, where is there a line or feature that's in the y-axis direction? And this line, right? So I'm going to click there, okay? But now, okay, our x and y need to be flipped. So I'm going to go ahead now and just check that guy, and then check that guy, and there we go. Everything is set up. Okay, so our positive y should be going away from us. Our positive x should be going to our right, and our positive z should be pointing upwards. Now let's come on over here to our stock, and we're going to change our mode here to fixed size box, and our width is going to be 0.5, our depth is going to be 0.5, our model position is going to be centered for both of them. And then for our height, though, we're going to set this now to 1.73, not 1.75, because if you recall from setup 1, we shaved off 0.02 inches of stock in our facing operation. So we now have a height now of 1.73 inches. Should be centered, okay? Actually, no, I'm sorry. It should be offset from minus Z, and it should be offset a distance of 0. Okay, and now we're going to come on over here to post process. And for our program comment, please write your name and please type in what you're working on, which would be our valve core removal tool, and type in your stock size, 0.5 by 0.5 by 1.73, and any other relevant information that you think will help you make this part. All right, when you're done with that, go ahead and select OK. All right, and the first thing we want to do when we're usually milling is face something off. So we're going to come on up here to 2D and we're going to select the facing operation. And we're going to grab our tool here from our valve core removal tool library. We're going to select our big face mill here, our 2.5-inch tool, and hit select. Okay, we're going to set our coolant now to disabled. And we are going to set our spindle speed here to 5,000 and our cutting feed rate here to 40 is fine. So all of these default values are good. For our geometry though, we're just going to select the top of that guy and the top of that guy. Okay. And then for our heights tab, everything is good. For our passes tab, let's set our pass extension to 2 inches. Now I set my pass extension farther for my students. Okay, so that will give my students ample time to stop the machine if the face mill looks like it's going to crash into the part or the workpiece. Okay, everything else looks good. Let's go ahead and select OK for this operation. All right, and you should hopefully get a toolpath that looks something like that. All right, and for our next operation, we're going to go ahead and do a drilling operation to make this hole that's right here in the center. So we're going to come to drilling, and we're going to select our drilling operation, and we're going to obviously change our tool. So we're going to come over here to our valve core removal tool library, and we are going to select the 5/32 or 0.165-inch diameter tool here. Let's select that guy. We're going to set our spindle speed here to 3,000 and our plunge feed rate here to 5. All right, and for our geometry, we are going to select that hole right there. Okay, and then our heights tab, we are going to select drill tip through the bottom. Okay, and then for our cycle now, since this is kind of a deep drilling, we're going to come on over here to chip breaking, partial retract, and we're going to set all these values now to 0.2, 0.2, 0.2, 0.2, and 0.2. When that's all done, once you have 0.2 for most of these, go ahead and select OK. And now what that will do is that'll do some chip evacuation for us. So if we simulate it, we hit play, you'll see this thing kind of go up and down. Okay. All right, so let's go ahead and exit that guy and start our next operation. All right, for the next operation, we want to remove the material around the cylinder feature right here. So to do that, let's come on up and do a 2D adaptive clearing. We're going to change our tool now to tool number 4, our 1/4-inch 3-flute end mill, flat end mill. Let's go ahead and select that guy. Our coolant set to flood. Our spindle speed is 5,000. Our cutting feed rate is 40 since this is a roughing operation. For our geometry now, okay, we're going to zoom in a little bit and we're going to select this circle right here. Okay, and it should look like that. For our heights tab, everything is good. For our passes tab, now this is very important. Select your optimal load. Let's set that to be 0.03. Okay, for stock to leave, we're going to leave 0.02 along the walls, and along the floors of our part, we're going to leave 0. Okay, and for feed optimization, this will slow our tool down in those corners because remember, more of our tool is engaged in the corners, which can cause accidents and stuff. So we're going to be a little cautious on this one, and we're going to select feed optimization to slow our tool down. And for maximum directional clearance, I'm going to go ahead and select 10. Okay, and then for reduce feed radius, we're going to set that now to 1.5. And then for the next option, reduce feed distance, we're going to select 0.1. And then our reduced feed rate, we want to slow our tool down to 15. Okay, and we're going to go ahead and select, uncheck that guy and select OK. And if you did everything correctly, you'll see these yellow portions here, which mean our tool is slowing down in these outer corners here, which is what we want. All right, so we just did a roughing operation, so you may have guessed that the next thing we need to do is a finishing pass. So let's come on over here to 2D contour. We're going to select the same tool, our coolant set to flood. However, because this is a finishing pass, we're going to slow it down, and we're going to use a spindle speed of 3,000 and a cutting feed rate here of 30. Okay, and then we're going to come on over here to geometry. We're going to select that guy right there. And for our heights, okay, we're going to do a selection here, and we're going to select that guy right there, and we're going to offset it just a hair, minus 0.002. Okay, just to kind of remove any burrs or anything left behind from our roughing operation. Okay, all right, and everything else in here looks good. Let's go ahead and select OK. All right, and there you have it. All right, so the next thing we want to do now is to remove the material here in this hollow cavity or slot here. So to do that, we're going to come on up here and we're going to do a 2D adaptive clearing. And we are going to change our tool because a 1/4 inch end mill will not fit in there. So we're going to come on over here to our valve core removal tool library. We are going to select tool number 2, our 1/8 inch flat end mill. Let's go ahead and select that guy. Our coolant's to flood. Our spindle speed is 5,000 and our cutting feed rate is 40. For our geometry now, we are going to go ahead now and select stock contours, and we want to keep it within that guy right there. And then for our pocket selections, we're just going to select the same thing. Okay, and then for our heights tab, everything here is good. For our passes tab, now this is very important because you'll break a tool. You want to go over here to optimal load, and we're going to set that to 0.018. Okay, and for stock to leave, this is a roughing operation, so we're going to leave behind 0.05 along the walls and 0.005 along the floor. So when you're done, let's go ahead and select OK. And hopefully, if you did everything right, you should get a tool path that looks something like this. And please remember to simulate it when you are done. Don't just go off of what I did. Make sure it looks correct. Okay. All right, so now we need to come through that same area with a finishing pass. So we're going to come on up here to 2D contour. We're going to use the same tool, coolant set to flood. However, because this is a finishing pass, remember we slow it down. So we're going to use a spindle speed of 3,000 RPMs and a cutting feed rate now of 20. For our geometry, it's going to get a little tricky. So listen, we want to select these lines right here. So I'm going to go ahead and click there. I'm going to double click up here. I'm going to hit open chain, and I'm going to click on that guy. Okay, and then I'm going to click on this guy, and I'm going to set my my extension length here. I'm going to set that to 0.1 for both of them. Actually, let's do that to 0.05. Okay, so we're going to set our extension length here to 0.05. So our tool kind of wraps around these fillets here and removes any burrs. And then we're going to go ahead and select OK. All right, and now we got to do the same thing now for the other side. So we're going to click right here, double click over here on the closed chain 2, and we want to make that an open chain, and we're going to basically repeat the same process we just did. Okay, and we're going to set that tangential length to 0.05 for both of them. Okay, and hit OK. All right, so you should have two toolpaths that looks hopefully something like that. Okay, all of our other default values here for heights and passes look good. Let's go ahead and select OK. And remember, you should be simulating this guy. So what you're going to see now is something that looks like that, hopefully. Okay, that looks good. All right, so the last thing we need to do now is to create these chamfers here. And remember, a good engineer will add chamfers, and a good machinist will add those chamfers as well to remove burrs, because if we can do any post-processing, such as deburring in the machines, okay, that'll save your company a lot of time and money if we can do it in the machine. Now, we won't be able to deburr this edge right here. Our tool simply will not get in there, and that's okay, but we're going to do the best we can by adding these chamfers right here, which will deburr these edges or corners. So to do that, let's come on up to 2D, okay, contour. We're going to come on over here and we're going to select our valve core removal tool library, and we're going to select our 1/4 inch chamfer tool and select that guy. Our coolant set to flood. Our spindle speed is 3000, and our cutting feed right here is 30. All right, and then for our geometry, we are going to click on that guy and that guy right there. Okay, and then our heights tab, everything is good. For our passes tab, okay, for our chamfer tip offset, we're going to select 0.03. All right, now remember, by selecting our chamfer tool, this option should show up. Okay, all the other default values are good. Let's go ahead and select OK. Okay, and when you're done, you should have a toolpath that looks something like this. All right, so please double check and simulate everything when you're done. Compare your machining times with your teammates and make sure everything looks right. And make sure your tool is doing nothing erratic and not causing any crashes or anything of that nature. Okay, so once you have that done, go ahead and save it and you're ready to make your part. All right, thank you so much for watching. We'll see you next time.